Hello YouTube viewers, welcome to my show Computer Wednesday. In today's episode, we're going to take a look at the UPS. So what it is a very simple device that acts as a buffer between your main power source and your computer. So all it will allow you to do is do what's called safe shutdown. Basically, if you have hard drives, they really don't like to be directly disconnected. You might corrupt the data that is stored in them. That's why, because of the data security, we want to make sure that there is no power that randomly cuts off. To protect against that, we employ UPS of various sizes, and it uses battery as an energy storage. There are other types of UPS, but none of them are available for general public. Like there is a rotary UPS where you have a flywheel that stores the energy. There is supercapacitor one. Again, these things are not available for general public. So for this reason, I'm just saying they store their most of energy in batteries, and it allows you to basically isolate your main computer from power to some extent power fluctuation, and to most extent power failures that happens in your grid. So let's say you connected your system to this and this to grid. If grid goes down, this will give you at least few minutes of power where you can safely do a shutdown. So we have to understand this topology is that it's not a standby device. It's not completely deactivated when you turn it off. It's using itself whenever you are connecting anything to it. So this has what's called auto transformer. Basically what does that mean is that many of you have seen that UPS does not allow power to flow through it if you have turned it off. So when you turn it on, the power that is coming in from the grid goes to an auto transformer. This is their first line of defense. What does this allow is, as you can see, it can handle a little bit of voltage fluctuations. This is a circuitry for 110 volt system or 120. So if you have from your grid low voltage comes in, it will switch to UPS first. During that time, it will switch to 110 volt. Basically it will make the auto transformer step up the voltage, and then it will disconnect the battery, and then again you will have the power directly coming from the grid. Now let's say you have over voltage, your grid goes over volt, and it will again disconnect the system. Then it will use the battery in that while, because any of you have worked with stabilizers know stabilizers takes a while to change. So in that while, just because your computer does not shut off in that while is trying to change, it switches to UPS mode. Basically you are running from battery power. You might hear it basically cut. You might hear this sort of sound from it, and it's a very simple device. It's just an auto transformer. There is a charge controller, there is battery, and there is inverter. Now there is a bit of switching delay. It's not like online UPS where there is absolutely no switching delay. There is a bit of switch delay, and earlier very old inverters used to switch in around 10 milliseconds to 15 milliseconds. This switch is very quickly, as quickly as possible. So their target generally is below 5 milliseconds. So your computer's capacitor should be powerful enough that they can hold a charge for 5 milliseconds, and this will switch. Generally they switch under that, and as they get older they might take longer. So all you have to understand is there is an auto transformer inbuilt into your UPS. So what are the pros and cons of this device? First is super cheap. Most of you have this. As you can see, Intex makes it, Microtech makes it, Eyeball makes it. They are super cheap. They are super cheap. You can just buy them off the shelf. They are quite simple. They are compact. Generally, they are one unit, as in like the battery is inside them. And you can buy them in large variety of power ranges, where you can have like one battery, dual battery, or sometimes 4 battery. So suffice to say, it's a very cheap arrangement. However, it does transfer fluctuation. This is not like an online UPS where no matter what happens into your grid, this will not allow you to transfer this, because every time there is a voltage fluctuation, it actually switches to UPS and then switches back to the grid system. There is a double switch happening every time there is a voltage fluctuation, and as I said, there is a millisecond delay. It's not instantaneous. So your actual equipment is actually getting a voltage fluctuation, and if let's say voltage fluctuation is happening below the auto transformer transforming range, as in like the voltage fluctuation is 5 volt plus and minus, it won't do anything. That 5 volt plus and minus will go through your equipment. For that reason, I specified if you had very precious electronics, you might want to use online UPS. Link in that I bar there. So for that reason, we use this as it is very cheap. That's the first point. You can afford it, you can just go out and buy it. But they do transfer fluctuation. So if you have like a lot of fluctuation between 5-6 volts and it's like, you know, constantly happening, your equipment will still get damaged, because this does not prevent it. And every time there is a voltage up or down which is within its range, it will switch to UPS, then it will switch up the transformer, then it will switch back to the main line. So during that time your equipment is getting a lot of fluctuations. So we have, many of you have recently, in recent times, have noticed a trend that all the inverters are also saying UPS come inverter. So what they are actually is very simple. They are only giving you a switch of UPS grade. Basically they're going to switch from battery power supply to your main line power supply in less than 5 milliseconds. That's the whole point. Now many of the, if you have seen the inverters, you have realized they have external batteries. Now this is crucial for them, as in my other video, link here, I have told you, like, the inverter does not control how long your equipment will last. It will be controlled by the battery. So like this is a 220 amp hour battery. You might let's say your power cut is very little, so you might want to buy a 150 amp hour battery. Or if your power cut is way too much, you might want to buy 220 amp or 250 amp. So as you can see, there are battery for every specific need and specific range with different milliamp hour rating and sometimes amp hour ratings. For this reason, like your conventional normal UPS have 7 to 9. That's it. That's the maximum generally they have for internal batteries. But outside battery, they will start roughly at 50 to 100 to, and 200 you are starting to reach into tubular territories, and it's quite big. And this is the reason, please don't connect big battery to your UPS, not because they won't work. They will work without any issue, but they are not designed to charge these big batteries. These batteries charge rate is very high. Like the current that they can take into it is generally rated very high. Like this battery can take upwards of 5 to 20 amps. Your UPS was not designed to give us that amount of power. It was designed to maximum give 1 amp power. So if this battery get discharged on your UPS, on your like, you know, crappy UPS where you just plugged in the cable from inside and you know, running this, it may not even be able to bring it back to life. It might be dead permanently, simply because it does not have enough juice on the DC circuit, and it's also not built to run 24/7. However, inverters are designed much more beefy and much more strong to make sure that they can handle this kind of batteries. For this reason, you have to be very careful. Don't just take a UPS and, you know, connect big batteries to it. It will not be able to handle it properly. And they do not have built-in stabilizer. That line interactive function is not there in most inverter. Some inverter may have it, but tread carefully here. Almost none of them have. So, and if you see something known as UPS mode in your inverter, what does that simply mean is that whenever the voltage goes either overvolt or undervolt, all it will do is directly switch to battery power. Now that's not an issue if where you live, where overvolt and undervolt is a rare occurrence. Let's say it happens once a day or twice a day, it won't be a, you know, big concern. However, if you live in a place where that's a constant thing, you know, you constantly getting in, let's say in 220 volt line, like I get 180 volt, 190 volt, sometimes 350 volt, the UPS, I cannot be in UPS mode because my battery will be completely discharged. This is why we use line interactive UPS for computers. And UPS mode is a very cheap way to get a proper UPS service out of it. So inverters are not designed as UPS. So what can you do is buy a pure sine wave inverter and then connect that to a UPS, normal cheap grade UPS. That way, whenever you are not in UPS mode, because I told you, like if you have a lot of voltage fluctuation up and down, either you connect a stabilizer to your inverter, or there will be issue that your battery will be completely discharged in UPS mode if there is a lot of power fluctuation. For this reason, you have to understand there is a difference between UPS and inverter, primary of which is one does not have an auto transformer built into it. And you can't just, like, you know, put big batteries into your UPS. You can do it, try it at your own risk, and you might create a fire hazard. So this was my presentation, and I think now I have completed my entire saga of UPS, every type of UPS. This was line interactive cheapest UPS. Before that I have done online UPS, and before that I have done an overview. So you can see, watch all those videos and get a full idea about how the heck this whole world works. So I hope you like this my video and learn from it. In that case, please like. If you didn't, don't worry about it, dislike it, and leave a comment what would you want to see next in the episode of Computer Wednesday. Subscribe, press the bell icon as I make video every day. And as always, thanks for watching.